Today we're going to talk about weak acids, strong acids, weak bases, and strong bases. As a review, the definition that so far we have for a base is some ionic hydroxide, an ionic compound that has hydroxide ions, that completely dissociates in water. Dissociates means this ionic compound splits into two separate ions, a sodium positive ion and a hydroxide negative ion. Negative and positive. Must be charged. The electron has been transferred away from sodium to the hydroxide. An acid is something that dissociates to produce hydrogen ions. Really, this hydrogen ion is going to combine with a molecule of water and makes H3O plus the hydronium ion. But a strong acid is one where all molecules will ionize to form H plus hydrogen ions, and those hydrogen ions will go on to connect with a water molecule to make hydronium H3O plus. Okay? When I say a strong acid, I do not mean a concentrated acid. There's two separate different pairs of words that we're going to use to describe acids and bases. When we say strong or when we say weak, we are speaking about the ability to ionize, to break apart, to produce hydrogen ions in solution. When we say it's strong, it means that all of the molecules ionize. When we say that it's weak, very few of the molecules split into H+. I'll show you some pictures. For now, strong bases ionize completely. Strong acids ionize completely. Strong acids are more reactive than weak acids because there's more H pluses in solution to react. In general, we talk about 6 main strong acids. We talk about hydrochloric acid. We talk about nitric acid. We talk about sulfuric acid. We talk about hydrobromic acid. We talk about hydroiodic acid and perchloric acid. Hydrochloric acid, nitric acid, sulfuric acid, hydrobromic acid, hydroiodic acid, perchloric acid. These are our 6 strong acids that you need to know. Are there other ones? There are a few, but these are the ones that I want you to remember. They are strong because every time I put any of these into water, every single molecule splits into H plus and whatever the anion is. In this case, the anion would be the iodide anion, I negative. Here it would be SO4 2 negative. It splits into ions, like we did when we did net ionic equations. A weak acid is a little different. In a weak acid, only a small portion of molecules ionize. Maybe 1 out of 100 will ionize, maybe 1 out of 10, something like that. Since less ions form, weak acids are known as weak electrolytes. Again, electrolytes are substances that split into anions and cations in solution. They're called electrolytes because they carry electricity. So, strong, splits completely. Weak, only some split. Maybe 1 out of 100. Let's say only 1 in 10 or 1 in 100. Depends on the thing, whatever. Only a few actually split. The other words that we usually associate with acids and bases are concentrated and dilute. Concentrated acid is one where there's a high ratio of acid molecules to water molecules. A dilute is one where there's a low ratio of acid molecules to water molecules. So let's take a look at these pictures and see if we can identify what's a strong acid, what's a strong concentrated acid, a strong dilute acid, a weak concentrated acid, and a weak dilute acid. Alright, so let's find some patterns here. Do we see the large circle attached to the tiny circle? Let's call this an acid molecule. Here is an acid molecule. It's got a hydrogen, that black dot, attached to some anion, A negative. Okay? Not dissociated. Not ionized. The two are still remaining in contact. We also have another acid, except this time it's missing its hydrogen. Its hydrogen has gone and attached itself to a water molecule over here. This acid is ionized. And here we have some other water molecules just hanging out. There's a water molecule. Let's put an oxygen with her. Here's another one that we were talking about over here. Hydrogens and hydrogens. This isn't a water molecule anymore because it's got 3. It's H3O with a charge of +1. This is hydronium. Here's another water molecule. Oxygen in the center. So looking at this picture, we have 1, 2, 3, 4 different acids with lots and lots of water. Since we have many more waters than we have acids, I'm going to call this dilute. There's more H2O compared to acid. Oops, sorry about that. I'm also going to label this as a weak acid. Why? So only some of the acid ionized. This is a dilute weak acid because of the only 4 acid molecules that were put into this picture, half of them dilute, half of them ionized. These 2 are 3 ionized. Sorry, excuse me. These 3 have remained attached to their hydrogens. They were not able to split up. Only 1 was able to ionize. Therefore, it is a weak acid. It's dilute because there are only 3 and not more. Oh, sorry, excuse me, only 4 acids and not more. If you compare it to this side, we have acid over here. It's no longer attached to its hydrogen, so it's an anion. It's got a negative charge. Here's another anion that must have once been part of the acid. Here's a 3rd. Here's a 4th. Here's a 5th. Here's my 6th. 7th. 8th. Ooh, 9th. Compared to that other one, this is definitely concentrated. there is many acids. And if I take a look, each of these acids was originally stuck to a hydrogen, but none of them still have their hydrogen. All of them have lost the hydrogen that used to be connected. When we see that acid has been ionized completely, no hydrogens attached to acid, we can say that it's a strong acid. Hydrogen has gone on each of the water molecules that it could find. Oxygens in the centers of each of the water molecules. We have a concentrated strong acid, dilute weak acid, concentrated strong acid. Let's look at the bottom one here. Here we have one acid still attached to the hydrogen. Here's another acid attached to the hydrogen. Third one over here. Oops, attached to the hydrogen. Fourth one over here. Oh, no longer attached. It's got a negative charge. Attached, 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 attached. All with accompanying hydrogens. Except for this guy here. So, we have many, many more acids compared to our first one. This is concentrated. But at the same time, it's a weak acid. It's concentrated because there are many acid molecules compared to water molecules. But it's a weak acid because the acid molecules can't seem to lose their hydrogens to solution, and as we talked about before, hydrogen in solution is what makes an acid an acid. Our final one, we've got an acid over here that's lost its hydrogen, an acid anion here, an acid anion here, and one over here. And we should have, here's a hydronium, here's one hydronium. Ooh, any more? There's another one. And some oxygens as long as we're here. In this case, we have a dilute. Dilute, however, dilute because there's only a few acid molecules, but strong because each of those acids lost its hydrogen to solution to make hydronium. So you have four options: a dilute weak acid, a dilute strong acid, a concentrated strong acid, and a concentrated weak acid.